welcome to Rajshekar classes on applied data science with Python. This is lecture number 637. In this lecture, I will continue my discussion on recurrent neural networks. Before understanding this lecture, let me show slides from my previous lecture, that is lecture number 635 and lecture number 636. Just go through all these things I discussed in my previous lecture, that is in lecture number 636. Just in continuation of my lecture, that is lecture number 636. Now let me discuss lecture number 637. Yes, these are the few slides from my previous lecture, that is lecture number 636. Now let me continue my discussion. This is lecture number 637. Imagine I have two reviews. Let's call my first review as x1. Let's assume I have one review which is, that is, let me say my first review is x1. Let me assume my x1 review is this phone is very fast. Let me assume I have second review. What is my second review? Let me assume my second review is this phone is good. How many reviews I have here? I have two reviews, review x1 and review x2. If you observe carefully, your x1 has 5 words. Just count how many words does it have? 5 words. 1, 2, 3. First word is this. Second word is phone. Third word is. Fourth word is very. And fifth word is fast. Isn't it? You have 5 words. You have 50k dimensional. Now, how much? What is my vector? Because you have 5 words, you have 50k dimensional vector, because each word is represented as 10k. Each word is represented as 10k dimensional vector, as we have seen here, because your vocabulary has 10k words. That's important, because your vocabulary size is 10k. Now x2 is represented as, how can I represent my x2? Now x2 is represented as 40k word, because it has only 4 words, isn't it? So your input size is changing, because one sentence has, your input size is changing because one sentence has 5 words, other sentence has 4 words. Let me assume there is one more sentence, x3. This input size is changing. x1 has 5 words, x2 has 4 words. Let me assume there is another word, other review x3, which has, let me assume, 20 words. Isn't it? First one has 5 words and second one has 4 words, and let me assume third one has 20 words. This is the key problem here. Let me assume there is another review x4 which has 200k, which needs 200k dimensional vector. Means, what does it mean? This is the key problem. What is the key problem? The key problem here, all your inputs are the sentences. They can be of different length. Your sentences could be of different length. You might argue, okay, if the sentences are of different length, just assume if the sentences are of different length, one other argument that you can make is try to fix this problem as follows. We will say my input vector x1. Let's say I have reviews x1, x2, x3, so on, xn. Let me assume there are n reviews, isn't it? Let me assume my x1 review has 10 words and x2 review has 4 words and x3 review has 15 words, xn review has 20 words. I will make maximum of all these reviews. Let's assume maximum number of words in particular review is 50. Just let it be 50, isn't it? You will argue, actually you build a vector which is of size 500k. Why? Because I have a review which consists of 50 words. Each word needs 10k, as corpus size is 10k. Therefore, let me assume you build a vector which is of size 500k, because the maximum number of words is 50 words in a particular review. I am assuming there is a review which has 50 words. That 50 words is a maximum number of words. If you have x1 with only 10 words, let me assume, what about x1? X1, I am assuming x1 has 10 words. Only fill the first 100k dimensions, and the rest of them you basically give zeros. This is basically, if you give zeros, this is basically is known as zero padding. Actually, performing zero padding on the vectors, isn't it? I am performing zero padding on vectors, isn't it? So for x1, you build 100k dimensional vector, because each word takes 10k dimensions. So you would argue that you build a vector of 100k, the rest of 400k, you just give zeros, isn't it? The rest of 400k you just give zero. Just see, only you are keeping 100k, the rest of 400k you are just giving zeros. This is one fix that you can think of. There is one more problem with this. Let's assume you have a query sentence which is of 100 words long. Let me assume after training I have a query sentence of length 100 words long. We don't know what the query sentence. Let me assume I have a query sentence whose length is 100 words. Query sentence means I can say it is test data, isn't it? What is training data? X1 is having 10 words, first review. X2 is having 4 words. X3 is having 15 words. This is my training data, isn't it? In a test data, you may get a query point with 100 words, which means now you need 100 words means what? You need 1000k or 1 million dimensional vector to represent this query point, to represent this query from test data. But your training vector is of size. What is the size of your training vector? 500k. This is one problem. Even with this fix, we have this particular problem. Let me go to second problem. Imagine the size of input here is, the input size will become massive. The input size will become massive in most cases. It will be just see, you are just building, you are just what's happening here. You are just building unnecessarily very large networks by just zero padding. I'm training such a large network, hundreds of thousands. Maybe you have million input vector, isn't it? Let me just million input vector, just unnecessarily. It is simply unnecessarily. Imagine the number of connections that you have. Imagine if you have 1 million inputs. Let me assume you have 1 million inputs here, and even if you have, let me assume, 1000 layers network, just look at the number of connections that you have. The number of entities in the weight matrix is going to be 1 billion, isn't it? Number of entities in the weight matrix will be going to 1 billion. You have 1 billion weights, isn't it? That 1 billion weights that you have to train. That's important, because 1 million here, 1 million inputs here. How many inputs you have here? 1 million inputs here. And in the next layer, I'm assuming 1000 neurons. So 1 million into, I can say 1 million into 1000 neurons means I will get almost 1 billion. Imagine that training a network. Imagine training a network. If you train a network with 1 billion neurons, it will just eat up all of your time. And I'm not cooking up this example. If you actually train a multi-layer perceptron problem, you can easily run into billions of weights, which will make the problem extremely hard to solve. And most cases, you just have to zeros because of zero padding, isn't it? So to avoid all these issues, people are said, let's design a new form of network. Let's design a new network from the scratch. That network is called RNN. We will see how RNN solves these type of problems that we have seen here. There are two problems. Just try to recall how many problems are there. There are two problems here. First, each your input is of different length. That is first problem. What is first problem here? This is my first problem. Each input is of different length. This is first problem. My second, you don't want to blow up. You don't want to blow up the number of weights. If you have more number of weights, it is difficult to train, isn't it? You don't want to blow up number of weights, unnecessarily make the network too hard to train. In the next lecture, we will understand the basic structure of recurrent neural networks, and in next few lectures, we will understand RNNs, recurrent neural networks, in more detail. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.